Okay, let's begin our lesson. Last week we mentioned oxidation, and we mentioned the equipment for the oxidation will be the furnace. But not only the furnace, we also have another kind of thermal processing equipment. It will be RTP, rapid thermal processor. For the RTP we mentioned, we can use the RTP to do the annealing, so we call it RTA, or we can use RTP system to do the oxidation. So we call this tool as the RTO, okay? So next time when you see A, you know this tool, the purpose for this tool will be annealing. When you see O, means we need to do the oxidation, okay? So RTA and RTO, they use the same tool, or they have the same tool, but for a different purpose, okay? And also you need to tell the difference between furnace and the RTP system, okay? Or after we finish today's lesson, or you can at least make three differences between furnace and the RTP system, okay? For example, this slide shows you for the furnace, it's a batch system, BATCH, batch system. It means we can put many wafers in the furnace, okay? For the first difference is for the furnace, it's a batch system, okay? However, for the RTA system, it's a single wafer system, okay? So one time we only can do the oxidation for one wafer, one single silicon wafer, okay? For the RTP system, okay? So this is the first difference, between furnace and the RTP system, okay? And then last week, how we compare with this is the Halolanto furnace, 水平的炉管, okay? And for the Halolanto furnace, how we show you, just like the vertical furnace, we do have the mass flow controller here, or to control the flow rate of the different gases, okay? So we do have the different gases. If I want to do the wet oxidation, I need to put the oxygen and the hydrogen into the chamber, okay? And in order to improve the growth rate, or sometimes we will turn on the HCl in order to increase the growth rate, okay? And the purpose for the burn box and the scrubber, how we write down here to let you know, usually for the oxidation system or for the deposition system, why do we need burn box? Why do we need burn box? Because we want to remove the toxic, flammable, and explosive gases. And also we need to use scrubber, how we need to use the water to remove some corrosive gases, okay? So I write down here to let you know the reason how we need some scrubber and the burn box. Okay, and this is the vertical furnace. So for the vertical furnace, you can see that it takes less space. It can save the area, because it's the vertical furnace. Okay, so we will we see the diagram for the vertical furnace. It's the same. It's almost the same. The same tool with the Halolanto furnace. But one difference is for the vertical 垂直的炉管, you can see that for the vertical furnace, you see we have the robotic arm,機械手臂, we have the robotic arm to transfer the silicon wafer, and we also have the quartz bolt. 荆州 we have the bolt, and then we have the bolt motor drive system. We have the flexibility to load the silicon wafer and unload the silicon wafer, and I can choose maybe the number 3 or number 5 silicon wafer must pull out or must load in. So I can choose which silicon wafer I want to take in or take out, okay? Because it's the vertical the vertical furnace. So you can use the robotic arm to choose which silicon wafer you want. Okay. However, for the horizontal furnace here, right? You see, today you cannot choose which silicon you want, right? Because if you want to take out the silicon wafer, you need to take out the bowl, or take out all of these 100 silicon wafer out and choose which one you want, okay? So you cannot choose which silicon wafer you want for this horizontal furnace, okay? So we have a table. We have a table to show you the difference between horizontal and the vertical furnace. Okay. So the first one, I used the blue color to highlight something I think is important. The first one, footprint. Okay. So we only remember, for example, for me, I only memorized for the vertical furnace. Okay. Because if you just need to memorize for the vertical furnace, or because it's the this slide want to highlight to you, vertical furnace is better than the horizontal furnace. And why? I use the blue color to show you why vertical furnace is better. Okay, for the vertical furnace, 垂直炉管, it's smaller. Okay, so the clean room footprint must be smaller. It's use less space for the vertical furnace. Okay, because it's a vertical. So we only use less space. We can save the area of the clean room. Okay, so vertical furnace is smaller. Okay, it makes sense, right? How about the second one? Parallel processing. It means it's ideal for the process flexibility. So for the vertical furnace, we do have the wafer motor drive system, right? So we can load and unload the silicon wafer during the process, and we can choose which silicon wafer we want to load and unload the silicon wafer. Load means we put the silicon wafer into the quart, and unload means we want to take out the silicon wafer from the furnace. Okay. So we can choose which wafer we want to load and unload from the quart or from the quartz tube. Okay, and it also can increase the throughput. Okay, and then for the most important one, I give you the start to show you. I think the most important one, of course, the area is important. We need to save the space, save the area for the clean room. But the most important is this one and this one, okay? The most important one for the vertical furnace is the gas flow dynamic. 气体动力学, gas flow dynamic is better. Or the gas flow dynamic is better for the vertical furnace. It means the gas flow is more. It's uniform. We can have the uniform gas distribution through each wafer, through each silicon wafer. So when you have the uniform gas distribution across each silicon wafer, it means the fin quality, fin thickness, will be uniform. Between different silicon wafers, or between two silicon wafers, or because you have the uniform gas distribution. Okay. For example, if I want to grow the silicon dioxide, so the oxygen, we can have the uniform oxygen distribution across the silicon wafer. So the uniformity within silicon wafer and between two silicon wafer will be better. Okay. 通常我们讲的均匀度指的是什么？一片 silicon wafer 里面的均匀度，以及 wafer to wafer 的均匀度，在同一批 lot 里面，在同一批货里面 wafer to wafer 的均匀度，还有呢 lot to lot uniformity。lot to lot 就是每一批 lot， 我第一次做跟我第二批 lot， 第一次做跟第二次做 oxidation， 它的 uniformity。所以我们说的 uniformity 很多同一片 wafer 不同区域的 uniformity。同一批蜡不同 wafer 的 uniformity， 以及不同批蜡就是我不同次做，今天做，明天做，lot to lot 的 uniformity，OK？、For the uniformity of the silicon wafer, we mean for the uniformity across one single silicon wafer. And also the uniformity, we mean the uniformity between two silicon wafer within the same lot. And also the uniformity we refer to lot or lot to lot uniformity. It means today I grow the silicon dioxide and tomorrow I grow the silicon dioxide again, and the uniformity between two processes are uniform, okay? So the gas flow dynamic is better for the vertical furnace, okay? And also the next one is the temperature gradient across the wafer. For the vertical furnace is smaller. It means we have the uniform temperature. We have the uniform temperature across the silicon wafer for the vertical furnace. Okay, so the temperature gradient is smaller. 温度差比较小，代表温度的均匀性也比较好。Okay, so the temperature gradient across the wafer is smaller for the vertical furnace. It means the temperature uniformity is also better for the vertical furnace. Okay, so today, not only the gas distribution is uniform, but also the temperature is uniform across the wafer for the vertical furnace. So it means we have the better ability for the vertical furnace. In school, we can show you today if I want to grow gas oxide. This is the gas oxide. I write down GOX for you. I want you to memorize. GOX is very, very common to use in IC fab because they don't want to write down gas oxide. So they prefer to use GOX, means gas oxide, okay? It's not a terminology, but it's the word IC fab will use all the time. So they will say GOX. When they write down the report, they only write down GOX for the gas oxide. So today, for the vertical furnace, the gas flow is uniform. The temperature is more uniform for the vertical furnace. So vertical furnace is better. So how can I know it's better? Today, if I want to grow the gas oxide for the horizontal furnace, the minimum gas oxide is around 3 nanometer. So it means I only can grow the 3 nanometer for the silicon dioxide. The minimum thickness of the gas oxide is only 3 nanometer. However, due to the Moore's law, I want to scale down the gas oxide thickness. But you cannot use the horizontal furnace. Okay. Today, if I want to scale down, I want the oxide thickness is smaller. I need to use the vertical furnace. Then, for the minimum gas oxide can be, can as thin as 1 nanometer. Okay. So I give you this number. This number is true in 交大奈米中心. Okay. So I cannot show you the real number for the IC fab, but this is the number for the 交大奈米中心. Today, if you want to grow the gas oxide, if you only use the horizontal furnace, the minimum thickness is 3 nanometer. Okay. However, it's still very thick oxide. So if I want to grow 1 nanometer, only 1 nanometer, you need to choose the right furnace, vertical furnace. Okay. So in order to grow thinner gas oxide. Okay. So that's also the reason why the IC fab they use the vertical furnace. Okay. Okay. So let's move on. Okay, you can read this slide by yourself. Okay, this is the summary or the summary for the previous table, so you can read by yourself. Okay. And for this slide or for page 40, so today this is, of course, this is the vertical furnace, right? Or vertical furnace. So we have the three heating long. 1, 2, 3, right? 3 heating long. We use coil. We use coil to heat the chamber. We use the coil to heat the quartz tube 或 the quartz tube 石英管 We use the coil 线圈用线圈来加热我们的石英管。石英管在哪里？石英管是里面的这个管子 ，OK？ We use the coil to heat the quartz tube. Where is the quartz tube? Quartz tube is here, okay? Quartz tube is here, okay? So we have 1, 2, 3, and this 3 heating long, okay? And also we have the thermocouple to detect the temperature, okay? Thermocouple here, thermocouple here to detect the temperature. 我们是用热电偶来测量它的温度。And also you see today I use the coil to heat the quartz tube. So it means the whole quartz tube has the same temperature, right? Today I use the coil to heat the quartz tube. So it means the whole quartz tube have the same temperature, like the processing temperature 1000 degrees Celsius, right? So it means the whole chamber, 整个腔体 the whole chamber, the whole quartz tube have the same temperature. So we call this system as the hot wall system. Hot wall system. It means the whole quartz tube, have the same temperature, okay? Not only the silicon wafer has 1000 degrees Celsius, the whole quartz tube have the same temperature of the 1000 degrees Celsius, okay? Today, I mean, if I do the oxidation, if right now, I assume right now I do the oxidation, I tell you, it's required 1000 degrees Celsius, right? So the whole quartz tube have the same temperature of the 1000 degrees Celsius. So that's the reason we call the furnace as the hot wall system, because the whole chamber, the whole quartz tube has the same temperature as the 1000 degrees Celsius, okay? So we say this system as the hot wall system, okay? So that's also the reason we can use the thermocouple to detect the temperature of the quartz tube, okay? We don't use the thermocouple to detect the silicon wafer. No, we don't do that. We use the thermocouple to detect the quartz tube, right? Because the quartz tube have the same temperature as the silicon wafer. So we call this system as the hot wall system, okay? And usually for this tube, we can use the quartz, or the silicon carbide. Silicon carbide can also sustain the high temperature, so we can use quartz or the silicon carbide, okay? So later I will show you for the RTP system. It's not a hot wall, it's the cold wall system, okay? So right now you just memorize for the vertical furnace, horizontal furnace, it's the hot wall system, okay? And this slide we don't go through the detail about the heating system, okay? We just show you how we use the thermocouple to detect the temperature, and we use the thermocouple to detect the temperature of the quartz tube, okay? And the typical ramp rate, the temperature ramp rate for the furnace is around 10 degrees Celsius for 1 minute. So today, how you can calculate by yourself? I just give you the example. Today, if you want to increase the temperature from 400 degrees Celsius to 1000 degrees Celsius. Or you can calculate how much time you need, because usually if we don't do the oxidation, the whole chamber, the whole quartz tube will maintain around 400 degrees Celsius. Standby is the standby temperature. This is the standby temperature for the furnace, okay? And 1000 degrees Celsius is the temperature when you do the oxidation, okay? So you can calculate by yourself today if you want to increase by 600 degrees Celsius, and how much time you need to wait until the temperature is 1000 degrees Celsius. Okay, so I just want to show you the furnace. For the furnace, it really takes time. So maybe for 1 hour or 2 hours, you can calculate by yourself. For the hours, you need to wait for almost 1 hour in order to let the temperature is increased to 1000 degrees Celsius. Okay, and then after you finish oxidation, you need to cool down. You need to cool down. When the quartz tube is cooled down to 400 degrees Celsius, then you can unload the silicon wafer. Okay. So until the temperature is cooled down to another 400 degrees Celsius, so you can unload the silicon wafer. So here and here, it must take 1 or 2 hours, more than 1 or 2 hours. So I give you this temperature and the temperature ramp rate. Just want to show you it's a very long process. It's waste time. It's really waste time. Because you need to wait until the temperature is increasing from 400 to 1000 degrees Celsius, because the heating element is coil, because we use coil to heat to heat the chamber. So today you use the coil to heat the chamber. You need to wait for 1 to 2 hours, and then you need to wait until it's cooled down, because the whole chamber is 1000 degrees Celsius. So you need to wait until the whole chamber, the whole quartz tube is cooled down to 400 degrees Celsius. It's another 1 to 2 hours, okay? It's a very long process. So I want to emphasize to you, it's a very, very long process. So do you think the IC fab, they want to do that? They don't want to do that, okay? Because they don't want to waste time to do the oxidation, okay? So later I will show you the IC fab, they do have another tool. They do use another tool because they don't want to waste much time, okay? Okay. I do love this textbook because this textbook show you what is really going on for the furnace. So today when you see this one, I just want to show you in IC fab. You see, this is the quartz tube. This is the quartz tube, right? And this is the silicon wafer, right? So do you still remember we mentioned today we can put so many silicon wafer in one quartz tube. So it means this is the batch system, right? This is the batch system because we can put so many wafers, okay? So the number here, you don't need to memorize the number, okay? Or for my final turn exam, or for this detail, you don't need to remember that, okay? Because it's not accurate for the IC fab. But I show you this pattern. I think the most important thing is you know some basic information, not the real number. Of course, it's not a real number, okay? So today, it's a batch system for the vertical furnace. And also, it's the hardware system, right? It's the hardware system for the furnace because the whole chamber has the same temperature. Or the whole chamber, the whole quartz tube have the same temperature. Not only the silicon wafer has the same temperature as the quartz tube, okay? So that's the reason we call it hardware system, okay? Okay, let's move on to see the wafer loading pattern. You see, I use the different color to show you. The green color shows you on the top of the quartz tube, and also on the bottom of the quartz tube, we have 4 dummy wafer. Do you remember what does that mean for the dummy? We show you what is the dummy. This here and here we have the dummy wafer. Dummy wafer means fake. It's not real. It's the silicon wafer, right? It's the silicon wafer, but this wafer is not for sale. Okay. So we call it dummy wafer. This chip are not for sale, because usually when the silicon wafer is on the top, on the bottom, it means and the edge of the tool, usually the outside quality is worse, okay? We don't want the worst outside quality, right? So that's the reason for this dummy wafer on the top, on the bottom. It's not for sale, it's not for the customer, okay? It's the dummy wafer, okay? But you say, why do I want to put the dummy wafer? Usually on the top and on the bottom of those 2 regions, the uniformity of the gas flow and the uniformity of the temperature is not good, okay? Here, the top and the bottom of the quartz tube, the uniformity of the temperature and the uniformity of the gas flow is not good. That's the reason the outside quality for the wafer here and here are not good, okay? Are not good. So that's the reason we don't use the wafer on the top and on the bottom. These 2 regions silicon wafer for our customer, okay? Because the quality is not good, okay? It's not good compared to the silicon wafer in the middle of the quartz tube, okay? But you will wonder, so can I just remove the dummy wafer? No, you cannot do that. You cannot remove the dummy wafer. Today, if you remove the dummy wafer, then, this wafer will become the dummy wafer, okay? Today, if you remove this 4 dummy wafer, then this wafer will become at the edge of the quartz tube. So this wafer will become the worst quality, the worst outside quality here, okay? So that's the reason you need to put the dummy wafer here, because the gas flow rate is non-uniform on the top and on the bottom, okay? So that's the reason we need to keep dummy wafer here and here, okay? Even though we know the quality is not good, but you still need to put the dummy wafer here and here, okay? 这个 dummy wafer 的概念在我们半导体制程设计里面也有。我们电晶体最旁边，我们会做很多不是很多，我们会各做1颗到2颗的 dummy 的电晶体。为什么？因为对于制程而言，最外围的永远是最差的，所以你不能让你真正好的电晶体放在最外面，那颗电晶体外面始终要有1颗电晶体作为什么 dummy gate dummy 什么的，它一定要有最外面一定还要有1颗电晶体来保护你好的电晶体。你看做这个制程也一样，你做的制程里面最外围的地方一定要有一个 dummy wafer，dummy wafer 在最外围。如果你把 dummy wafer 移掉，那最上面的 wafer 就变成 dummy wafer 了 ，OK？ And also for the blue color, we still need some test wafer. Test wafer on the top, on the bottom, and in the middle, because sometimes we need to do some destructive analysis. So we need to use the test wafer to do the material analysis. For example, like the surface roughness. When we use AFN, to know the surface roughness, we use the probe to contact the silicon wafer, right? But when you do that, we damage the silicon surface. So that's the reason when we do some destructive analysis, we want to do the material analysis, we need to use the test wafer to do the material analysis. We don't use the production wafer. Production wafer is for sale, for NVIDIA, for Apple. So you cannot use the product. You cannot use the real product to do the testing, okay? Oh, so we do have the test wafer, okay? Oh, but like I mentioned, oh, you don't need to memorize. Oh, the dummy wafer is 4, the test wafer is 1, okay? You don't need to do that because even me, I don't know the accurate number for the IC fab because for the different generation, they have the different pattern, okay? So I just let you know the concept, but you don't need to memorize the 401, okay? It's not important. You just need to know we have dummy wafer, we have the test wafer. The test wafer is do the destructive analysis. 我们要做一些破坏性的分析哈。最简单的哈，我们做 AFN 那个探针，只要一接触到 silicon wafer，silicon wafer 马上就产生了4个洞。哦，所以像这种破坏性分析，你一定要用 test wafer 去做量测。哦，你不能拿那个要给 NVIDIA 的片子去做量测。好，那卖给 NVIDIA 的片子全部都已经 damage 了。Okay, so this slide we are going to talk about RTP system, and here unlike furnace, it's the cold wall system. It's the cold wall system. So the most important difference between RTP and a furnace, for the furnace, it's the cold wall system. Why? Because for the RTP system, they use the tungsten halogen lamps. And where is the tungsten halogen lamp? Here. Here. Here is the tungsten halogen lamps. So for the RTP system, they only have the high temperature here on the top of the chamber. Okay, only here. Here is the tungsten halogen lamps here. Okay, and this is the real chamber. So we put the wafer. We put the silicon wafer here. We put the silicon wafer here. Okay, and here is the heater, right? Here is the heater. Okay. So heater is only on the top of the chamber here, and we put wafer here. You see, the chamber is very small, right? One time we only can process one single wafer, so it's a single wafer system. Okay, for the RTP is a single wafer system. It's the single wafer system, okay? It's not a batch system. Batch system is for furnace. For the RTP, we only can process one single wafer. So it's a single wafer system, okay? So for me, I will rather to memorize this picture, okay? If I can memorize this picture, I know the heater is here. The wafer, one single wafer is here. So when the heater is here, the heater is only on the top of the chamber. So it must a cold wall system, okay? It's a cold wall system. And also we only allow one single wafer. So it's a single wafer system, okay? So I can memorize this figure, okay? So you will know the difference between RTP system and the furnace. Okay, we take 10 minutes for a break.那个助教可以来一下吗？
you.